Hi everybody and welcome to this video. In this video, we're going to have a look at how to solve some general problems on mixed sequences. So this one here, we don't know which type of pattern it is. So we first have to find out which pattern it is, and then we're going to have to complete the next three terms. So having a look at the first one, we can always look for the first difference, which we get by subtracting. So 3 minus 1 is 2 and 5 minus 3 is 2. So the first one is a linear term, a linear pattern. And why do we say it is a linear pattern? Because it has a common first difference. And then the next term, few terms we get by adding 2. So then it will be 7, 9, and 11. Let us have a look at the next one. So I'm going to write it out over here. So we have 2, 5, 10, and 17. So let's calculate the differences. So we have 3, 5, 10 minus 5 is 5, and 7. So there's no common first difference, so we know it's not linear. So let us have a look at our second differences. So our second differences are 5 minus 3 and 7 minus 5, which is 2. So because it has a common second difference, that means that we know that it is quadratic. This is a quadratic pattern. So then we can see the pattern. To get the next one, we're going to add 9. So 17 plus 9 is 28. And then we're going to add 11, which will give us a 39. So then we're adding 11. And then what we're going to add is 13. So then what we're going to get is 39 plus 13, which is 52. Okay, so if it has a common first difference, it is linear. If it has a common second difference, then it is quadratic. Let us have a look at the next one. So I'll write the question here. So it's 4, 2, 1. Now if we look at the first differences, we get 2 and 1. So there's no common first difference and there's not enough terms to see the second difference. But what we can notice is that when we divide, so 2 divided by 4, we get a half, and 1 divided by 2, we get a half. So it has a common ratio. And if it has a common ratio, then it is a geometric pattern. And then we're going to go to the next one by multiplying by that common ratio, which is a half. So then the next term should be 1 times a half, which is a half. The next term is a half times a half, which is a quarter. And then the next term is a quarter times a half, which is 1/8. Okay, so let's have a look at the next one. Number 4, let's first check our differences. So 5, 10, 20. The difference between that is 5 and that is 10. So we can see we don't have a common first difference, but you'll notice that if we multiply by 2, we get to the next term. So it has a common ratio of 2, so it is geometric. And then the next terms are 40, 80, and 160, multiplying each term by 2. Let's do the next one, number 5. So here we have 1, 8, 27, 64, 125. So you can see that there's no common ratio. There's no number that we can multiply to get the next term. So let's look at differences. So 8 minus 1 is 7. 27 minus 8 is 19. 64 minus 27 is 37. And 125 minus 64 is 61. So there's no common first difference. Let's have a look at the second difference. So we have 19 minus 7, which is 12. 37 minus 19 is 18. And 61 minus 37 is 24. So again, we have no second difference. So it is not linear, it is not quadratic, and it's not geometric. So let's go for a third difference. So 18 minus 12 is 6, and 24 minus 18 is 6. So there's a common third difference. And if it has a common third difference, you can guess what it would be. If it's linear with a common first difference and quadratic with a common second difference, that means with a common third difference, it is cubic. So these are your numbers cubed. So this is 1 cubed, 2 cubed, 3 cubed, 4 cubed. The next one will 5 cubed. The next one will be 6 cubed, and 6 cubed is 216. And then we have 7 cubed. So then 7 to the power of 3 is 343. And lastly, we have 8 cubed. So 8 to the power of 3 is 512. So this is a cubic pattern. Okay, so let us look at number 6. So number 6, I'll just write it out here. So we have 0.5, 1, 1.5. So we can see there's no common ratio. There's no number that we can multiply by that will give us the next term this all the same time. So it's not geometric. Let us look at our differences then. So we have 1 minus a half is 0.5, and 1.5 minus 1 is 0.5. So it has a common first difference, which makes it linear. And if it is linear, then we add the common difference to get our next term. So this is a linear pattern. So what we're going to have is 2, and then 2.5, and then 3. We're adding half each time. The next one is 10, 7, 4. And again, there's no common ratio, so it's not geometric. We cannot multiply by the same number. Let's look at the common differences. It's 7 minus 10, which is negative 3, and 4 minus 7, which is also negative 3. So again, there's a common first difference, which makes this linear pattern. So then to get the next term, we're going to add negative 3. So this one is linear. And then we're going to minus 3, so then it's 1, and then we're going to minus 3, so it's minus 2, and we're going to minus 3, so it's minus 5. Now the last two have a few alphabets in it. Let's see. So we have 1a plus 2 and 2a plus 3. So this divided by this, so we're dividing first. So we have a plus 2, and this divided by this is 2a plus 3 over a plus 2. So it doesn't have a common ratio, so it is not geometric. Let's look at our differences. A plus 2 minus 1 is a plus 1. And here we're going to subtract 2a plus 3 minus a plus 2, which is 2a plus 3 minus a minus 2. So if we simplify that, we get a plus 1. So can you see we have a common first difference? And a common first difference makes it linear. Okay, so it looks a bit complicated with the letters, but we approach it the same way. So we're going to add a plus 1. So the next term will be 3a plus 4. We're going to add a plus 1 again, so it will be 4a plus 5. And then we're going to add a plus 1 again, which is going to give us 5a plus 6. Okay, so let's look at it. The last one, we have 1, 2p, and 4p squared. 1, 2p, and 4p squared. So let's divide. 2p divided by 1 is 2p, and then 4p divided by 2p, 4p squared divided by 2p is 2p. So we have a common ratio, which means it is geometric. So then what we have is we're going to have to multiply by 2p. So the next one is 8p cubed. The next one is 16p to the power 4, and the next one is 32p to the power 5. Okay, so let us just summarize the results that we have. So if it has a common first difference, then what we will have is a linear pattern. If it has a common second difference, then we have a quadratic pattern. If it has a common third difference, then we have a cubic pattern. And finally, if it has a common ratio, so not a difference, then we have geometric pattern. Okay, so we have covered each of these patterns, well, except for cubic, individually. So please watch our previous videos if you have found this video a bit confusing. If you found it fine, then please move on to our next video on mixed sequences. Thank you for watching. Bye.